So, hello everyone, welcome to the lesson. And today I'll be talking about random forest. And along with random forest, I'll also give you a little bit of recap about decision tree. So, first of all, before starting the lecture, to understand random forest very nicely, you have to know about decision tree well. So, if you don't know anything about decision tree, you should first go and learn about the basic building blocks of decision tree, how a decision tree is created, and then you should come back to the lecture. And by meaning the basic, I mean you should learn about Gini impurity and all that stuff, information gain and all that, variation reduction in variance and all that. And then you should come back to this lecture where I'll be explaining about random forest, right? So let's start the lecture. Random forest. So the first thing that we need to know about random forest is that it is a supervised learning algorithm. Supervised learning algorithm. So I hope you know about supervised learning algorithm, unsupervised learning algorithm, reinforcement learning. So I'm not going to explain them in right here. So, and another important point about random forest, or another reason why random forest is so useful, is that it can be used for both classification and regression problems. Used for both classification and regression problem. Classification and regression problem, right? So this is the first 2 points that we need to know about random forest. And next, basically, random forest is basically a collection of decision trees. Random forest, or RF, I'll from now onwards I'll write RF for random forest, is basically a collection of decision tree. A collection of decision tree, right? So random forest is basically a collection of decision tree, and this is why this is also called a bagging technique. A bagging technique. I'll talk about bagging technique more on this bagging technique later when I'll explain things about random forest. So first, let's go ahead and understand random forest. So as I told you, that random forest is basically created using decision trees. So first we need to know a little bit about decision tree, right? So let's go ahead and understand decision tree a little bit. Okay, so first of all, what is a decision tree? First of all, that we need to know is that what is a decision tree? What is a decision tree? Right, so the decision tree is basically a graphical way of going to a possible solution. Graphical way of going to a possible solution. Graphical way of going to a possible solution based on a series of decisions or questions. Decisions or questions. So this is a very basic thing about decision tree, right? This is a very basic definition of decision tree basically. Okay, so now let's see a structure of a decision tree, right? So I'll be talking about a structure of decision tree, right? So the structure of decision tree. So let's see how decision tree looks. First of all, we have something which is called the root node. and this is the first node or the first split that happens, the first split, that is called the root node or root node or root anything can be said, right? The next that we go on, and this root node gets split into two nodes, two directions, right? So where we come is basically to the second position, which is a node. Also this is a node. These nodes are further splitted, right? And what we get is basically a leaf node or a leaf leaf. Once again, these nodes are further splitted, and what we get basically is a leaf. Okay, so this is the basic terminologies in decision tree. Apart from this, there are many other terminologies like Gini impurity and all that. But before just jumping into that, I would like to give you a small use case or how decision tree is framed. Another thing, the important thing that I forgot to mention here is that these root nodes or these nodes are basically divided on the basis of the features in a dataset. For example, if I say that I have a dataset where I have to predict whether a person or whether a student is able to crack a examination or not, right? So I'll have some features in my dataset, like the features on which the predict on whose basis the prediction will be made. Let's say I have some uh, for features, like suppose the first feature is, do the student work hard, right? Or hardworking or not, hardworking, yes or no. Okay, next feature that I have, let's say, does his basics are clear or not, right? So for clearing the exam he needs to have his basics clear, right? And then again some splits will be there. If then third, maybe there can be another uh, feature that is like, does his parents support him for the examination or not, does his parent gives him guidance or not. So these are some of the features. These are not any proper features, I know, but I'm just trying to explain. So basically this is how things work. Let's see. um First, let's say, do the student work hard or not, or hard work or not, right? So I'm just writing here, hard work. If yes, then I have to check again. And what I will check, does his basics clear or not. Yes, then I have to again add some questions like, does his parents support him. If yes, then he will qualify, let's say. Then 1 and he qualifies, or 0, right? This is a very basic and crude example just to make you understand. Now I'll just draw the other part of the tree. If no, then he need to first get it cleared, or he will fail, like there will be a 0. If no, then 0, right? Once again, if his parents don't support him, there's a chance that he will fail, most probably he will fail, right? So no. So this is basically how a decision tree works. Now another thing about how these root nodes, like how to decide which one is the root node, like there are three features: hard work, does his basics are cleared or not, and does his parents support him or not. Now I can choose anyone as the root node, like there is no mandatory thing that this hard work is the root node or not. So for that, what we do is we take in Gini impurity, or we try to calculate the impurity. um I'm not going in depth of Gini impurity, just I'm giving you the formula for Gini impurity. Gini impurity is basically the measure of the Gini impurity, measure of impurity in a node, right? Gini impurity is basically the measure of impurity in a node. Now what's its formula? Let's see the formula. One minus probability of yes whole square minus probability of no whole square, right? So this is the formula for Gini impurity. If the Gini impurity is, the lesser the Gini impurity, the better is the better it is, right? So what we do basically, okay, so we calculate the Gini impurity. I hope you know how to calculate the Gini impurity, how to use this formula, what is the probability of no and what is the probability of yes. I hope you know this. Otherwise, there can be a different like lesson where I'll explain this, right? So we calculate the Gini impurity of all the features and one with the least value is taken to be the root node, right? So one with the least value is taken to be the root node, and then again we divide that, because as long as there is impurity, we keep dividing the tree, or we stop the division when the impurity of without the division is lower than the impurity after division. We stop splitting or division, we stop splitting or division once the impurity or Gini impurity is less before splitting than after splitting, right? So I think up to these things are clear. What is Gini impurity, how a basic decision tree works. I know this is not a very proper explanation of decision tree, but this is basically a recap of decision tree. If you know about decision tree, this will just freshen things up for you. Now let's move on to random forest again, and let's see how random forest works and all that stuff. Now, so one important thing about how random forest works is that the reason why it's random, because we select the root node randomly, right? We select the root node randomly, and also split the feature nodes randomly. We don't split it like the way we did in decision tree, right? So now let's start with how RF or random forest works, right? So first of all, first we first we will learn so first we will split the data set into n k rows, right? I'm explaining this. N k rows, right? For example, let's say there are 256 data points, 256 data points, right? Or sample examples, right? 256 training data. Okay, now among this 256 we will divide this 256 into let's say k. Like, let's say I want to divide this 256 into let's say 8 groups, right? So I'll divide this 256 by 8. which is basically 32. So I'll split this data set into 32 groups, right? And this 32 groups including repetition. I'll explain what this including repetition means. So this 32 groups including repetition, right? And then I will use this for training the decision tree, right? So I think this is the basic thing. I think this is clear. Now second thing that we'll do, um, among the k features. Now among the k features, okay, another thing that we can do is, let's say there are, let's drop the term k from here, and let's say columns, right? Let's say there are m number of columns, m columns or features, right? M columns or features. We can also select random features also, called columns. Features we can select randomly, like if there are m columns, we can select like m by 2 and m by 2 features for each and every row. We can select that randomly as well. Now what the point is, calculate the node among the m columns. Calculate the node D using the best split, using the best split. Another thing here, I need to say that, let's say this is 256 is the total number, so let's say this is D. So D will be always greater than K, right? Nothing to say here, you can understand this. Okay, now so first what we did, we basically taken the data set and split it into k groups. Then we calculate the node D using the best split, right? So these are the basic two steps, and these are the basic two steps that we take to create a random forest. Now let's see how this works properly, right? So let's say this is a data set that we have, right? Let's say this is a data set, and let me name this as D. This is the number of rows, right? Rows means data points. Okay, and let's say M here. This is the number of columns. Columns means number of features, right? Now I'll be having some decision trees here. DT, let's say I'm dividing it into 4 decision trees. DT, right? I'm dividing it into 4 DTs. Some row and column samples, right? Row and column samples. Now with repetition means, when I'm selecting the row and column samples for the second decision tree, there will be some points that were included in the first as well, right? So this means with repetition. So when I'll be selecting a row and columns from the second sample, when I'll be selecting a row and columns from the second sample, there will be some points from the first sample as well, right? This is basically with repetition. This is basically what it means with repetition, right? Okay, so up to this things are clear, right? So now how the prediction is done, let's say we are going for a classification, right? So binary classification, so the output will be in basically zeros and ones. So let's say this gives a value of 0 here, this gives a value of 0 here, let's say this gives a value of 1 here, and this gives a value of 0 here. So we will take the majority vote and we will say the value is basically 1, right? We will take the value to be 0, because this is the majority vote, right? So because this is the majority vote. I hope up to these things are clear. Now in case of regression as well, we can do regression as well. We will get some values from all the decision tree, and depending on the type of distribution, we will do basically, what we will do is basically we'll take the mean of this values that we'll get. Let's say if this is a regression, then let's say I'm having a value 100, let's say I'm having a value 105, I'm having a value 95, I'm having a value 98. So what we can do is basically, if the depending on the distribution, we can either take the mean of all these values or we can take the median of all these values, right? So I hope up to this things are clear. Now the point comes why we do random forest when we have decision tree. Basically, there's a problem with decision tree, and that is decision tree has low bias and high variance. Now, why RF, in spite of having DT or decision tree, right? Why RF in spite of having DT or decision tree? So basically, the problem with decision tree is that it is having low bias and high variance. Just wait, I'll explain what is low bias and high variance. Low bias, high variance. Now, low bias means the decision tree works very well with the trained data set. Very well with trained data. Very well means the error is very less, right? So what does very well means? Very well means that the error of the decision tree in case of the training data set is very low, right? But in case of test data set, it has a very high error, so doesn't work very well with, does not work very well with test data, right? So I think up to these things are clear. It works very well with trained data but does not work very well with test data, and this is a condition that is called the overfitting. This is a condition that is called the overfitting, and the basically random forest is able to tackle this problem because because what we do is basically we split this data set. So the decision, and we use so many different trees, we train them with different data but actually from the same source, right? We train all the decision trees from different data but actually from the same source, right? So this basically tackles this problem of low bias and high variance, or the overfitting problem. Now this thing about low bias, high variance and overfitting is very important, because this things also is very important when we'll be doing hyperparameter tuning in deep neural networks, right? There also you have to check whether your neural network is overfitting or underfitting. If the bias for the trained data, if the error in trained data is very high, then we say something that is underfitting. Or if the bias for the trained data is low but it is high for the test data, then we get overfitting, right? So I hope all these concepts are clear, how random forest works, how decision tree works. I know I haven't explained decision tree in a much depth, but this was just explaining, this was just a recap of things. If you know about decision tree, you will understand what I have explained properly. Apart from that, I think you have understood how random forest works as well. So thank you for watching, and bye.